So good morning, everyone, and thank you once again for joining us. First, I'd like to say that if you were with the Ag Crops team a couple of weeks ago for Precision U, I see a lot of familiar faces there in the participants. Some of this information will be repeated just a little bit, but what I'm hoping you'll find is that weather and climate obviously have a lot of varying and diverse aspects on or impacts on different areas of agriculture. So my purpose today is really to set up some basic foundational information about both long-term patterns, but also kind of taking a look at last year as a snapshot and looking at a particular site and location to think about, or at least set up the questions of how weather may be impacting diseases here. So hopefully just, setting up a really easy pitch to Pierce to take over after my presentation to go a little bit more in depth into the specifics with disease and the like. So again, thank you for being here, and let's go ahead and get started. So, I'd like to provide some overview and kind of break down, what am I talking about between weather and climate or forecasting and such. And, I like to start where we experience weather. How do we experience weather? I think it can be encapsulated in a picture like this, right? We can really sense or feel ourselves out in the cornfield, near the cornfield here on a warm July day. This happens to be Augalaize County here. Humidity's probably starting to rise a little bit. We see the puffy clouds and the like. So we're always sensing these weather variables. Now, as meteorologists, it is key. What we have to do is we have to make some forecasts. So we have to turn what we see and sense around us into some symbols and some information that we can display on a map to talk about how things are changing over a given period of time. And we know that the scales that we're operating on here when we deal with weather are very frequent and high-paced changes. Temperatures rise very quickly, fall very quickly. Conditions change rather abruptly, and we have to be able to adapt to those conditions. And I think farmers excel at this, being able to adapt to conditions that come along from weather. Now, over a long period of time, we can collect this information to develop some ideas or concepts about patterns, how things are changing over time, and then be able to take that information and then put it back into the community, right? So we're taking useful information and making it usable to the community. So that's something I think, I take very personally and very important for me, being able to translate that data into, okay, how do we use that data? And in today's example, we're talking about weather and impacts on disease. So again, weather being those high frequency changes, when we think about changes over, minutes, seconds to minutes, eventually all of those can be accumulated into certain patterns. And so when we talk about weather patterns, this is essentially what we're talking about: the motion of storms, the changes in the temperature on a yearly basis, seasonal basis. After a while, when we kind of look at the broad scale, and this is just an example here of showing storms moving across the surface of the earth, we start to really depict these patterns. We know, for instance, much of our weather moves from west to east across our region, across our country, but it's not that way everywhere. If you go to the equator, it's moving from east to west. They take on a little bit different characteristic across the Southern Ocean here, close to Antarctica. They're moving a lot faster because there's not as much land in the way to interact with the weather, the systems. So over time, these weather patterns establish the types of temperatures and moisture that we come to expect. And that's what climate is: the slower varying aspects, averages over longer periods of time. We can talk about a temperature over the course of a month or 3 months or a year or 100 years, right? So it's really important to think about the period of time that we're evaluating those changes. And so probably most of you by now have seen this. I play this every time, but I think it's a good illustration of weather and climate here. So again, as you're out walking your dog, the dog has some natural tendencies, some chaotic nature. It could be hot during a cool January. It could be cold during a warm June. So So that dog is like the weather. It moves back and forth based on natural tendencies toward fire hydrants and the like. But we can still explain the pattern from a mean sense, an average sense, by the path that the dog walker's taken. Maybe it's you out walking your dog. So that is the climate. The dog walker is the climate that we can describe that chaotic path on a more average basis. And of course, that also depends on the time frame. So the longer the time frame, the smoother that line is going to be that describes the path that the weather, or in this case, the dog is taking. So it's very just a good illustration of those two. And I'm going to talk weather and climate now for the rest of the program. So we'll start with the 2020 kind of Midwest growing season climate overview of last season. It was in Ohio, our 11th warmest March through November on record. And what I'm showing you here are the spatial differences compared to our long-term mean. Right now, that is 1981 to 2010. So we're comparing this March through November through the average of all March through Novembers between 1981 and 2010. And you can see that, you know, in Ohio, it was warmer than average. We had some warmth across Michigan, northern Illinois, back through Iowa as well. On the left, this is the daytime highs and how they differ from average. On the right, these are nighttime lows. So you'll see that our overnight lows, we had more spatially warm, you know, there were more areas of the map that were warmer than average at night compared to during the day. And that's actually one of our long-term trends that we've seen as well. We could break down the seasons. Last spring, it was slightly, you know, average to slightly above average. We actually had some really cool weather in April and May in Ohio, if you remember, and we'll dive into that just a little bit more. We followed that with near record warmth, top 10 record warmth across a lot of the Midwest, including Ohio. And then we continued those warm temperatures into our fall. We had fairly dry soils, which really helped perpetuate those warmer than average conditions throughout much of the fall as well. As far as precip goes, this is what the rainfall looked like during the March through November period. Again, anywhere from, you know, 20 to 40 inches of rain across the state, depending on where you were. A little bit higher up in the Northeast. As a matter of fact, location up close to, you know, up in the Northeast actually had the most precip for the entire year this year, around 58 inches. And if you remember the last few years, we were running some locations across southern Ohio in the mid 60s to 70 inches of rainfall, so well above average. But we had a big difference. You know, most of the state was above average for this entire period, except for the Northwest counties, which were below average, and we'll break that down a little bit more as well. So big differences between our spring and our summer, right? We had a wet spring generally across the entire state, followed by a dry summer for much of the state. So again, when we think about impacts on diseases, these wet springs, what do the wet springs possibly bring about? And are there any mitigation or impacts from a drier summer, for instance? So, you know, just thinking about some of the climate impacts on what we're seeing. So what I'm going to do now is I'm going to pick a site, and I'm going to pick on Bucyrus. Or as the French say, Bucky Roos. Yeah, we're going to pick on Bucyrus here in north central Ohio. And the reasons I think will become clear also more as Pierce presents his presentation. But we're going to look at Bucyrus a little bit closer. And of course, this is how Bucyrus experienced the temperatures last year. So these are the daily highs and lows in the gray bar. And then the record highs or lows for that day are given by the dark blue and the dark red. So, you know, we can start looking at this and we can see we had record warmth last winter, both in January and February, long, you know, good stretches of very warm weather, just like we're sort of experiencing this year as well, much above average over the last 30 days. Then comes along, and actually March was above average as well. It was a warm March, but then we followed that up with frequent late season freezes in April and May. We had freezes to, you know, to mid-May here in north central Ohio. We can also pick out the fall warmth. You know, we had temperatures hitting the 80 degrees in Ohio for the first time in November in some locations. So very, very warm conditions in the fall. But I'm also, you know, kind of wanting to break down a little bit of that growing season here, the May through October period, which we didn't see anything that was really challenging our daily highs. But again, it was very warm, especially during the summer. And this, of course, is the time where we had corn planting, growing, silking, and maturing. So I want to break that down a little bit more. We're going to look at the weather summary from a precipitation standpoint as well. So this is the daily rainfall at this particular site for the entire year last year. What you'll notice is we've had at this site 3 events between an inch and an inch and a half, and 3 events over an inch and a half. Or in 6 days, this site picked up 22% of its annual rainfall, which was close to 42 inches. For some perspective, you just have to go to Fulton County in Northwest Ohio, where they only picked up 26 inches for the entire year. So big gradient, a strong change in precip just between Crawford and Fulton County, for instance. About 28% of the rainfall fell during spring and 24% during summer. So it was drier during our summer, but you'll notice these events right here. Big events happening right around some important key dates here from a corn growing perspective. So on the 24th of July, August 2nd, August 29th, and September 8th, this is when these big, four big events occurred. So, Pierce and I were talking, we were thinking about this program. And so what I wanted to do is just, again, use Bucyrus as an example here. So, based on corn trials information, and I provided the link here and back and forth with Pierce, I wanted to look at this particular hybrid that he was working with, using the growing degree days to silking and also black layer to basically look at the GDDs and these dates using the U2U growing corn growing degree day tool. So based on the growing degree days and black layer of the hybrid, I was able to estimate then, based on the planting condition on May 27th, silking occurring around the 27th of July, black layer on the 12th of October, and then this field was harvested 11/18. All right. So using those dates, again, looking more at the weather that occurred around this period of time. So what you see here is a graph between planting and black layering. Okay, so and you're looking at a lot of different information here. The black line in the middle is the daily average temperature. So that's the average of the high, which is provided in red, and blue, which is the average, it is the daily low provided in blue, and the black line is the daily mean. Okay, so around this silking time, right, started investigating, okay, the 21 days leading up to the silking here on the 27th of March. We had average highs around, in the upper 80s, average lows in the mid 60s, and about 3 inches of precip for the 21 days leading up to that. For the 21 days following the silking date provided by the GDDs, we were about 5 to 6 degrees cooler in our max highs, about 4 degrees cooler in the lows, and about 3.5 inches of precip during that time. Now, if you look at the average is around the long-term historical average. The mean temperature is around 72 with a fluctuation between 62 and 83. So we were well above average for the 21 days leading up to silking, and afterwards much cooler. And if you look even closer at really the first 10 days of August, we had a lot of nights here that were in the low to mid 50s. So that's what's circled in blue. So the question is what impact might this have on the development of certain diseases? And again, this is just providing a platform or to think about the weather and the impacts in this case. And Pierce will go into a lot more about the specifics of the disease. But again, kind of cliffhanger here, there, obviously there are differences in the weather around this period of time, but the story is very complex as you'll see when Pierce presents a little bit later. All right. So what about larger perspective? Our 2020 perspectives, our 2020 numbers finally came out last week. 2020 for the globe is now the second warmest year on record since 1880. It was only behind 2016 by what we call statistically insignificant amount, 0.04 degrees Fahrenheit. So it essentially tied 2016 for the warmest year on record. Our top 10 warmest years since 1880 have all occurred since 2005. So if you were born after February of 1985, you've never experienced a cooler than average month compared to the 20th century mean. Okay, So conditions continue to warm uh, regionally, locally, and also globally, again, over this longer period of time. It's important to think about over the longer period of time. And why does that matter for agriculture? Why does it matter for disease here in Ohio, right? So as our temperatures warm, we get changes in the amount of energy that gets basically absorbed by our atmosphere. The atmosphere, the greenhouse gases like carbon dioxide and water vapor, they don't care about visible light from the sun. They care about all the what we call long wave radiation, or that heat coming off the Earth's surface. They absorb that energy and the temperature rises. As temperatures rise, then more of that energy that's coming off the surface gets absorbed by these particles and doesn't escape to space. So we get this feedback loop between rising temperatures and increased greenhouse gases, and then increasing our temperatures, which again drive stronger evaporation from the surface, because we have, a water cycle here that consists of precipitation that's falling, running off, trees, the ground, basically, the sun helping to evaporate moisture from the surface, trees through evapotranspiration bringing moisture up through the roots into the leaves and transpiring it to the atmosphere. That rises in the atmosphere, condenses, and it becomes clouds, and you develop precipitation. So we have this water cycle. But as you warm up the earth, you intensify this water cycle. So not only getting increases in precipitation, but you can increase the evaporation rates from the surface as well, right? So you can, if you don't get that precipitation, then you can intensify drought conditions, just the like as Amanda alluded to in the opening. So if we look across the U.S., it's very important to think about changes in our climate from a very localized or regional perspective, because it's not going to look the same everywhere. Wildfires and heat waves and droughts, that's what's really inherent to the West. Long-term droughts, right? If you go to the southeast and the eastern U.S., we are more concerned about North Atlantic hurricanes, the strongest of those, the Cat 4s, the Cat 5s, all increasing in frequency since the early 1980s. So those are the big impacts. And then when you look at our region, the Midwest, we're not as concerned about wildfires. We don't see them as often. We do see impacts from hurricanes and tropical systems, but more specifically, we think back to, 22% in some years, like 18 and 19, we were seeing 40 and 50% of our rainfall falling in fewer than 10 days of the year. Okay. And that's really challenging us from a lot of perspectives, ground erosion, nutrient loss, but also these wet conditions and warmer conditions have impacts on diseases and disease prevalence as well. The other big story is just the fact that these extreme weather events are increasing in number. Again, if you were with us for Precision U a couple of weeks ago, the final numbers of 2020 weren't out yet. We were at 16 through the end of October, but the final number is $22 billion weather and climate related disasters just in 2020. So a tremendous amount of highly impactful events. Again, just speaking to the fact that we've seen an increase in these extreme events. And in the face of those events are often in Ohio through water, rain-related disasters, flash flooding and flooding, wetter conditions overall, warmer conditions as well. And that's what's really kind of inherent to the changes that we're seeing here locally. So these are the changes in seasonal temperatures over the last 30 years. Now, I think it's important to note that long-term changes, just looking at changes over 30 years, while it provides a nice scope, because most of us remember 30 years ago in 1990, it's still, right? It's still, when you look at these trends over a 30-year period, that's not a long time. So a lot of times we do focus on changes between mid 20th century and today. But for the sake of just looking at what we've seen over the last 30 years that we're all familiar with, we've seen big changes in our spring, summer, and fall temperatures in particular. Southern Ohio, a lot warmer during spring, upwards of 3.5 degrees warmer during our springtime now. In the summertime, that sort of shifts to the north. A lot of that has to do with the fact that our Great Lakes are warmer as well. And so the warmer Great Lakes can keep those temperatures warmer during the summer. We don't get as much of a cooling effect. And then across the board, our fall temperatures are really increasing, and especially fall temperatures at night, increasing some 4.5 degrees, even 5 degrees in some locations of Ohio, just over the last 30 years. So that September through November range. And of course, these warmer temperatures can have impacts on disease prevalence and transmission. And so if we're looking at our precip trends, again, mostly wetter conditions. Winter there in the upper left, spring upper right, a lot of areas of Ohio being covered by those wetter conditions. Certainly in the fall as well, and then in the summer we get some interesting monthly trends. And so while most of the summer is wetter than average over the last 30 years, if we look at a month like July, we can see some drying trends there in west central, northwest, and north central Ohio. So again, this idea where you have a wetter summer overall because of the bookends, but you've got that dry central growing season portion. And how does that impact disease is a very good question. So again, more information, long-term trends over that May through July period that are critical, as Pierce will point out, looking at diseases here. So we can see our May trends, and I'm honing in a little bit longer. I'm going back to 1960. Okay, so for some of the folks out there, going back to 1960 here and looking at, our Mays are increasing in temperature, our Junes have increased in temperature. It may not, a half a degree, 0.6 degrees, that's average for the entire state, right? What difference does that make? Again, these aren't the ups and downs of our daily temperature. These are longer term changes overall, but you can see a lot of variability, right? There's a lot of variability. This May, for instance, was cooler than average for the state, but we've had some very warm Mays as well. A lot of variability in May and in June. What we've seen during July, as you mentioned, statewide, it's a flat trend. So even though we're seeing overall warmer conditions, by the time we get to July, those trends are not nearly as significant. Okay, so it's very, very important to think about. And then precip trends as well. Again, looking at May and June, increases in that amount of rainfall, a lot of variability, but pretty flat in July. Okay, so seasonal differences do make a difference. And so this whole idea about our winter and spring leading up, our planting seasons, we're not so much focused on, the planting conditions as we were last time, but just looking at May through July here. 5 of our top warmest May through Julys have occurred since 1990, including 2012, 2018, 2010. And 7 of our top 10 wettest years have occurred since 1990 for the months of May through July. So you see 15, 17, 19, 04, 03. Clearly, we're warmer, we're wetter during that period of May through July overall, with some of those monthly differences, and of course, our annual variability. So where we see things moving into future is a lot like what we've seen over the last 50 to 60 years. We see large changes driven by winter warming, overall warming, and overnight temperatures. Not so much our daytime highs during the summer, although we will start to, most likely those creep up as well. But with more water vapor in the atmosphere, it tends to limit those daytime highs during the summer, but our overnight lows are much warmer. So we're looking at mid 21st century changes about 3 to 5 degrees Fahrenheit warmer than what we've seen, okay, and what we've experienced over the last 30 to 40 years. If we look at precipitation, it's again the off-season driving winter, spring, and fall increases in rainfall. What impacts does that have on the development of diseases? Things are, overwintering in our fields. Spores are around and available to then infect plants the following season, but also seeing those summer dry periods, right? So a decrease in the amount of rainfall precipitation during our summertime. So if we step back and we look at, again, you've seen this probably ad nauseum here, our climate, the climate of Ohio, is really shifting and transitioning. We can think of us as on a move toward the south. So if you think about diseases that are in, more tied to southern states and southern regions, perhaps we're increasing the susceptibility of seeing these diseases here in Ohio as well, right? More the increasing that susceptibility to diseases we might not have seen, but also, providing conditions that can be a little bit more conducive to some of those diseases. And of course, there's a lot of various factors here, and the story is very complex, but certainly that is how we're trending when we look at our overall information here. Okay. So kind of a summary, obviously, weather had a role to play in the localized disease pressure during 2020. It's kind of a question mark. It depends on where you are. It depends what your fields look like at what time. Certainly our global and Ohio climate trends are clear. Ohio is warming. Precipitation is increasing our total, not just the amount, but also the extreme events. And we're seeing these seasonal shifts in precipitation, especially to wetter fall, winters, and spring. And so what do those wetter conditions in the spring portend for our disease seasons moving forward? This overall warmer, more moist environment, wet spring and autumn conditions may lead to increasing disease pressure, but the story is really complex. And that's where, obviously management is critical, identification, understanding these diseases, and that's really what Pierce is going to pick up and talk about in the next section. So with that, I'll go ahead and turn it back over, and I think we can take some questions if there's some questions out there.